Hi guys, so this is the solution for the 2015 paper 1 question 3. So the question asks, first the question gives us f of x equals minus x squared plus 12x minus 27. For the first part, it gives us a table and asks us to complete the table. So for part A, so the first value in the table, x is equal to 3, and they actually gave us that, so they gave us that to be 0. And they gave us 4 and 5 also, so then the next value that we need to figure out is x equal to 5. So what we're going to do is we're going to sub in 5 for x in our f of x. So we're going to say f of 5, I'm not going to have enough space. We're going to do f of 5 equals minus 5 squared plus 12 by 5 minus 27. So then we're going to get minus, so we keep the minus there and we square the 5, so 5 squared is going to be 25 plus 60 minus 27, and so that's going to equal to 8. And you need to watch your signs for this part here. You want to square the x value and then that whole value squared becomes a negative. Okay, so that's x equal to 5, and we got 8 for that, so we'll put 8 there. Then we do the next ones as the same way, the exact same way, so our complete table is going to look like x and f of x. We have 3, 4, 5, 6, 7, 8, and 9, and we get 0, 5, which they gave us, we get 8, which we just calculated, and then doing it the exact same method. I won't do them out here because it takes too long. You get the rest of the values for the table. So then the next part, part 2, asks us to use this table and the trapezoidal rule to find the approximate area of the region bounded by the graph of x and the x-axis. So here we use our formula of the area equals h over 2 by y1 plus yn. So that will be y1 will be the first term and yn is the last term. So if you've 5 terms in your table, n is 5, so the 5th value. So then we're also going to do plus 2 times y2 plus y3 plus all the y values that we have up until value y of n minus 1. So if we continue with the same example, that would be y2 plus y3 plus y4 if we had 5 terms. So that's what the n minus 1 term there means. So when we sub in our values for that from the table, we get, so we'll have a equals, and h here is going to be the change in x, and our x terms are 3, 4, 5, 6, so the change is just plus 1, plus 1, plus 1, so change of x is equal to 1. So moving on to complete our values, we have an area equals 1 over 2 times 0, because that was our first term in the table, plus 0, as that was our last term in the table, plus 2 times all the other terms in between. So 5 plus 8 plus 9 plus 8 plus 5, bracket. So then we want the area equals a half, and all of that added up is 70. So the area is equal to 35. So the next part of the question, BI, asks us to find the integral of f of x dx from the values 9 to 3. So that looks like this. 3, 9, f of x dx. And now if you'll remember, these are the same values of x given to us in the table. So we want to say we had a graph. We don't know what it looks like, but say it looks like this. 9 will be there and 3 will be there. So we want to find the area in this interval for which we have the values of x for in our table, and which we used to calculate the approximate area in the question before. So when you integrate something, you find the area under the curve. So we're doing the same thing but a different way from the previous question. So the first thing we will do is we will write down, start a new page, f of x is equal to minus x squared plus 12x minus 27. So we want to find the integral of that. So 9 to 3 of minus x squared plus 12x minus 27, and then we add in dx here. So then that will equal to, so the x squared, the minus stays, so we keep the minus. We increase the power by 1, and then we divide by the power, plus 12x, we do the same thing, so this is x to the power 1 if it's just x on its own. So we have 12x squared divided by 2, and because the 27 is a constant, we add the x, so we do minus 27x, and then we need to put in plus c here in case there was a consonant here. When we differentiate this, if we differentiated this line here, if there was a consonant here, we would get this line, but the consonant would disappear if there were one. So we need to just account for the fact that there might be one there, and that's what the plus c does here. So then we still need to keep our intervals from over here, 9 and 3, and we'll sub those in later. So then the next step is to sub in our integrals. So we'll do the highest one minus the smallest one. So we'll sub in 9 for x, and then we'll minus, and we'll sub in 3 for x. So I'll show you how we do that now. So we'll do minus 9 for x cubed over 3 plus 12 by 9 squared over 2 minus 27 by 9 plus c. And then we'll do minus, and we'll do the same. We'll sub in 3 for all those places. Minus 3 over 3. We need to cube that 3. Plus 12 by 3 squared over 2 minus 27 by 3 plus c. So then once we sub in all of those, we're getting our answers to be minus 2, 4, 3 plus 4, 8, 6 minus 2, 4, 3 plus c. So that there are answers for the first one here, and you'll need to be careful of the signs. So when you're doing this, you cube the 9 and then you keep the minus like that. So we'll do the same thing for our next bracket. So our next bracket is going to be minus 9 plus 54 minus 81 plus c. So then the next step is to multiply this minus sign here, into all of the components in the bracket. So that'll change to a plus, that'll be a minus, that'll be a plus, and then that will be a minus. So we'll just write out our final. So we have minus 2, 4, 3, plus 4, 8, 6, minus 2, 4, 3, plus C, plus 9, minus 54, plus 81, minus C. And you'll see here how our plus C and our minus C will just mean that there's no C at all. So then all of those added up is going to equal to 36. And you can see how that's similar to our area approximation of 35 from the question before, but it will just be a little bit more accurate as we were integrating rather than using the trapezoidal rule. So then the next question asks, part BII, it asks us to find the percentage error in the approximation of the area from question 1. So we have the true value to be 36, and so true value equals 36, and approximate value we know to be 35 from part 1. So to find the percentage area, we first have to find the difference. So we have the difference. So we have 36 minus 35 equals 1. And then we need to find the percentage. So the error in our first calculation was 1. And we got 1 out of the 36 wrong. And to get that as a percentage, you multiply by 100 over 1. And then that's going to be equal to 2.7778. And we can round that out to 2.8% error from our approximation to our true answer.